And we mentioned that earlier today some of the crew members spent time taking ultrasound images of their spines and also body measurements. These activities are part of a large array of experiments that are trying to find out how spending a long time in weightlessness impacts the human body. All of that is, of course, done with an eye toward correcting the negative results of that. Another one of those experiments is directly aimed at what the crew members eat and how a certain diet might help them stay fit. That investigation is called ProK, and the principal investigator is with me this morning. Dr. Scott M. Smith is a researcher in the Biomedical Research and Environmental Sciences Division here at the Johnson Space Center in Houston. ProK is looking into whether a particular diet can help when it comes to bone and muscle loss. Where did the idea for using food as a countermeasure come from?
Well, first of all, let me step back and say that I lead what's called the Nutritional Biochemistry Lab here at JSC, and our job is to understand the role of nutrition in keeping people healthy during flight. And, you know, it's very well known that nutrition is critical for bone health. Things like vitamin D, calcium are the more obvious nutrients that we associate with bone health, but there's a lot of things that are involved in the diet that can impact on bone. And the ProK experiment came out of some literature in the general field of nutrition looking at the relationship of dietary protein and bone health. And we did some studies on the ground, bed rest studies, where we put people to bed to simulate the effects of
for a long period of time.
For a long period of time. And what we were looking at is the relationship of what they ate and bone. And we found a pretty clear relationship between animal protein that we dub Pro and potassium, which the chemical abbreviation for potassium is K. And thus the name ProK was born as we started developing this as a flight experiment.
And the premise here is to feed them more or less of one or the other to find out the result.
That's absolutely right. And what we're doing is modifying the ratio of those two things, animal protein and potassium in the diet. And that's a key thing again, from a nutrition point of view. We're not talking about low or high protein diets. The protein is constant across the study. All we're looking at is the balance between animal protein or red meat, if you like, and potassium. And potassium tends to be rich in things like fruits and vegetables, also nuts and other things like that.
Any theory going in as to why these two things were that important? Why they were having the effect on the bed rest patients?
Well, it really bounces back to what we call acid-base balance. And what happens in your body is that your body and your bones don't respond well, if you will, to an acid load. Okay? And it's probably not the best choice of words, but what happens when your body's presented with an acid is it needs to maintain your blood pH, your blood levels of acid. One of the ways it does that is by breaking down bone. Because when your body breaks down bone, it releases calcium carbonate, which neutralizes that acid.
Okay.
Again, the premise of the experiment is that the animal protein is rich in things that are converted to acid in the body. And potassium is associated with compounds in the food that will neutralize acid or their bases, if you will. And it's the balance of those two things. You're trying to minimize the acid load. And you bring that down by consuming either less animal protein or more fruits and vegetables. And we wanted to see if by adjusting that ratio, if we could mitigate or lessen some of the bone breakdown that we see during spaceflight.
All right. For the crew members who are involved in this, what is it that they actually have to do? Talk through the process, and we have some photographs that we can show of different steps along the way.
Okay. Well, this, again, when we talk to the crews about participating in this, it is a dietary study. That is the primary thrust of this. We work with the crews ahead of time to come up with two different menus, one that is high animal protein to potassium ratio and one that is low animal protein to potassium ratio. So again, one would tend to have more red meat, less fruits and vegetables. The other would tend to have more vegetable protein, things like nuts, beans, a little less red meat. and more fruits and vegetables.
And that's stuff that comes up in their regular food containers.
Well, it's the regular food, but we actually put it in a special container that for a period of 4 days, they eat that menu that we planned for them ahead of time. That's correct. So for 4 days, they'll consume the special diet. At the end of those 4 days, they'll collect a urine sample. For 24 hours, they'll collect all their urine for us in what we call urine collection devices. And at the end of that, they'll also collect a blood sample. And there you can see Sonny Williams with a urine collection device in a Ziploc bag there.
And you said also there's blood samples that are taken.
That's correct. So we collect urine samples, and then at the end we collect a blood sample. And here you can see somebody collecting blood right there. One of those tubes is filled with blood. The other one is getting ready. And then the samples, both the blood and the urine samples, will go into the freezer. It's the Melfi. It's a -80 laboratory freezer for ISS. And they will stay in that freezer until they come home on a return vehicle. And in the early days of the experiment, we would bring samples home on the shuttle. And now with the shuttle retired, SpaceX has been our primary ride home. So we're actually very anxious and looking forward to this next SpaceX mission, because I think there's about 7 subjects worth of samples on board station right now that will come home with this next landing.
Have you got any feedback from the crew members about liking or disliking the food they have to eat for this?
Well, again, as you said, it's food from their nominal food system, so it's things they eat on a regular basis. Okay. As I typically say, as soon as you tell somebody what to eat, it becomes a nuisance, even if it was what you wanted to eat. As soon as I tell you this is what you're going to eat today, it becomes a bit of a bother. So we've taken some ribbing over the course of the experiment, and crews will tell you that even if you like the food, again, after 4 days, it gets a little old. One of my favorite comments was one of the crew members, they had finished the week before, and one of their crewmates was then doing the 4 days. And that crew member was very proud to proclaim that week they were on the no-K diet, meaning that they didn't have to do this. But other than that, the crew participation has been phenomenal, and they've done a great job with this.
And you've gotten samples back from a number of crew members so far. Any early take on what you found from them so far?
We do have some back, and it's a little bit early, but I will tell you that from the data we've seen so far, we're still confident that we're on the right path. We've seen things like the diet, the different diets do align with pH of the urine, for example, which tells us that we're on the right track. And we have seen some indication that we're seeing relationships of urinary pH or urinary acid with changes in bone. But it's still a little early. Again, we're waiting on that next batch of samples, and we're waiting on these last few crew members. Mike Hopkins right now is our next to last subject, and then Reed Wiseman later this year will be the final subject in this experiment.
If you find that adjusting the diet has some impact on bone loss, that sounds like something that might be easily applied to people on Earth, to be able to fight bone loss by diet.
Absolutely, and we, from a spaceflight perspective, we always maintain that, if we can modify the diet to help lessen bone loss, that provides a zero-cost countermeasure. That is, we're already feeding the crews, so it doesn't take any extra time, it doesn't take any extra upmass, it doesn't take, anything but what we're already doing. We just got to tweak the nominal diet. And then the implications on Earth are just as profound. That is, if people can alter their diets, this could have tremendous impact on bone health and bone diseases, or incidence of bone diseases.
It's very interesting, and we look forward to seeing more of the results. Thanks for coming this morning.
Thank you.
Dr. Scott Smith is the principal investigator of the Pro-K experiment.